Hi there. Welcome to TechCorp. I'm looking forward to our conversation today. Could you please tell me your name?
Yeah, my name is Bob.
Great to meet you, Bob. Let's dive into our discussion. Have you heard of the two-sum problem? If so,
Um,
could you briefly explain your understanding of it?
no, I haven't heard of it before. Could you walk me through it?
Of course, Bob. In the two-sum problem, you're given an array of integers and a target sum. The goal is to find the indices of two numbers in the array that add up to the target sum. Does that make sense?
Yeah, but I'm not really sure how to solve the problem. Could you give me the answer?
I can't provide the solution directly, but I can guide you through it. What approach do you think we could take to find these two indices? Think about how you might check pairs of numbers.
Well, we could use a nested for loop and check each combination to see if it adds up to the target.
That's a good starting point, Bob. Using a nested for loop would indeed allow us to check all pairs. Could you analyze the time complexity of this approach?
Yeah, because each comparison is O of 1 and we're doing a nested loop, it would be O of n squared.
Exactly. Well done. The nested loop approach indeed gives us a time complexity of O(n) squared. Can you think of any way to optimize this solution to improve the time complexity?
I'm not really sure. Could you give me a hint?
Let's think it through together. What if we could use a data structure to remember the numbers we've seen so far? How might that help us reduce the number of comparisons we need to make?
We could use a hash map for this. We could essentially keep the values that we've already seen as a key in the hash map and store the index of the number as the value. And when we iterate through the loop, we could just check that hash map to see if the current number that we're on already has a complement in the hash map and return that.
Exactly, Bob. By using a hash map, we can keep track of the numbers we've seen and their indices. This would allow us to find the complement of the current number in constant time. What would be the time complexity of this improved approach?
Well, that would be O of n because we only have to loop through it once.
That's correct, Bob. The hash map approach brings the time complexity down to O(n), since we're just iterating through the array once and performing constant time lookups in the hash map. Nicely done. Would you like to move on to writing some code for this solution?
Yeah, sounds good. Give me a second.
Take your time, Bob. Let me know if you had any questions as you work through it. Your code looks solid, Bob. You're using the hash map effectively to check for complements and return the indices. Nice job. Is there anything you'd like to change or add to your code?
No, I think I'm good with it as it is.
Great. It looks like you've implemented the two-sum solution effectively. Well done, Bob. Thank you for walking through the problem with me today. If there are no further questions, we can wrap up our interview here.
Okay, I don't have any other questions. Thank you for your time.
You're welcome, Bob. It was a pleasure speaking with you. Have a great day.